Okay, I'm going in the quiet mode here. Hey, it is lesson number 4 of unit number 13. So we want to be able to look at surface area, still surface area, believe it or not. But we are now looking at regular pyramids. Bum, 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 bum. Excitement, excitement, excitement. Here we go. And again, we're looking at a three-dimensional solid. It's a polyhedron. It's got a polygon for a base, and it's got triangles for sides. So the lateral faces are all triangles. Notice that the height goes from the base to the vertex, and it's got to be perpendicular to the base. The vertex is the fancy name for the point at the top of the pyramid. And of course, the triangles on the sides are going to be called our lateral faces. They meet at a lateral edge. Base edge is where we talk about the lateral face meeting the base. So the height, of course, is one of the things that's going to come into play. The area of the base can become very interesting. If we're lucky, it's just going to be a square. If we're not so lucky, it can be a really interesting shape that makes it more convoluted to find the area of it. And then there's another piece of information we're going to need besides the area of the base and the height. And even the perimeter of the base. There's something else that's going to be popping up. Okay, now we're going to be dealing with regular pyramids. So the base is going to be a regular polygon, and so if it's four-sided, it will be a square. If there are 6 sides, it'll be a regular hexagon, so every side will have the same length, etc., etc., etc. And of course, we know how to find area of regular polygons, and we know how to find the perimeter of a regular polygon. Now, notice in the picture there's something else going on here. There's something called a slant height. All right? Because the height of the pyramid is not the same as the height of those triangles. Right? When we're trying to find the area of each side of that pyramid, each polygon on that pyramid, we're going to have to find the area of those triangles. And if you remember, area of a triangle is 1/2 times its base times its height. And so the height of the pyramid is not the height of those triangles. So we have to look at the slant height. Notice the slant height is also not one of the edges. It's got to go straight up the center of that triangle. And of course, it's got to be perpendicular to the base of the triangle. The reason why we won't do a non-regular pyramid, they don't have a consistent slant height. If it's not a regular pyramid, it gets very tricky to try to figure out all the different surface areas of all the different faces, and so we don't go there. We stick with the regular pyramid. All right, surprise, surprise, it's still going to be lateral area plus the base, right? It won't be plus 2 bases, there's only 1 base. So it's going to be lateral area plus the base. We're going to have to find the area of the base. We're going to have to find the perimeter of the base. And we're going to need to know the slant height. So for the lateral area, 1/2 times the perimeter times the slant height. Now, with the prism and the cylinder, it was just perimeter times height. Notice there's a 1/2 on this one. That's because area of a triangle is half of the area of its corresponding rectangle. Right? 1/2 times base times height for a triangle. So instead of perimeter times height, we want half of the perimeter times the height. But notice the height we're using is the slant height, not the height of the pyramid. And so surface area, well, we just take the area of that one base, add the lateral area, and we've got it. So instead of 2b plus L, it's just b plus L. So area of the base plus 1/2 times the perimeter of the base times the slant height. Okay, so let's dig into this, and we're kind of picking one that's a little bit trickier because we've got a regular hexagonal pyramid. Remember, we name all of our objects off the base, so if the base is a hexagon, we're going to call it a hexagonal pyramid. And if every side of the base is equivalent, we'll call it a regular hexagonal pyramid. Okay, perimeter. That's easy. There are 6 sides. Each side is 10. 6 times 10 is 60. Lateral area. Piece of cake. 1/2 times the perimeter times the slant height. Fortunately, we're given the slant height. 1/2 times 60 times 14. And I can either use pencil and paper. I would not recommend trying to do this in my head. Or you can grab a calculator. 420 would be the lateral area. Area of the base. It's a regular polygon, so it's 1/2 times the apothem times the perimeter. Thankfully, they gave us the apothem of 5√3. So it's 1/2 times 5√3 times 60. Of course, half of 60 is 30. 5 times 30 is 150. So I've got 150√3 for the base. So surface area, area of the base, plus the lateral area. And if I want an exact answer, I'm stuck right there. 150√3 plus 420. If I want a decimal approximation, I can grab a calculator. I can do 150 times the square root of 3. And then after I get that answer, I can add 420. Comes out to about 679.81 square feet. Again, I don't put the label in with every single step I'm doing, but at the end, when I compile an answer, I add the label so we know what we're talking about. A little bit more straightforward because it's a square base. That's going to be super easy. Perimeter, 4 times 10. 4 times 10 is 40. Lateral area, 1/2 times the perimeter times the slant height. And, the height is 12, but it looks like there's an error. There's an arrow pointing to the slant height, but I don't see a number. How am I going to figure this out? Well, if the side of the square is 10, the distance from the center of the base to the bottom of the slant height is 5. And of course, I've got a right triangle. So the square of the legs, when I sum those together, it has to be the same as the square of the hypotenuse. 5 times 5 is 25. 12 times 12, 144. Add those numbers together. Remember to take the square root. Again, if we're just doing plain old algebra, we'd have plus or minus 13. But we know in geometry, our measurements need to be positive, and so we just used 13. The slant height is 13. Notice the slant height actually has a greater value than the height of the pyramid. 1/2 times the perimeter times the slant height. 260 is my lateral area. Area of the base, piece of cake. All right, it's a rectangle. 10 times 10 is 100. Remember, a square is a rectangle. right? Rectangles are just length times width, so 10 times 10 is 100. Surface area will be the base plus the lateral. And I don't have to worry about grabbing a calculator and computing anything because it's not like I've got pi or square root, right? It's not one of these, hey, do I leave it exact or do I change it to a decimal? I'm lucky. The exact answer is the exact answer. 360 square units. Well, Super Cat might not be quite so exciting as Bat Llama, but we've got what we've got. So we've got a worksheet which is going to involve the surface area of our regular pyramids. And then IXL, it might be a little bit more time consuming because a lot of the IXLs lately, you just want to kind of like click the correct choice. Here you might be finding yourself having to do some calculations, and it'll be much, much slower with the IXL today.